Good morning, children. How are you all? I hope all are fine. Welcome back to the class. Children, today our topic is non-uniform motion. So, what is meant by non-uniform motion? When a body travels unequal distance in equal intervals of time is called non-uniform motion. Suppose, see here, A, B, C, D like this. So, A to B distance 10 meters, B to C 20 meters and C to D 30 meters. So here the time is 5 seconds. 5 seconds they are covered the in time 5 seconds. So here see, though unequal distances but they are covered in equal intervals of time. So that one is called the non-uniform motion. Clear, children? So here also in your textbook see, a cyclist moving in a straight road. The distance covered by him with respect to the time. Here time they are given 0, 1, 2, 3, 4, etc. like this, and distance he covered 0, 1, 4, 9, 16. So he covered unequal distance but in equal intervals of time. So this is the non-uniform motion. Clear, children? Next, what is the observing of motion in a ball and inclined plane? So this is an inclined plane. So see here. Now take a ball and release it from the top of the inclined plane. Here one ball we have to release from top to down. So the position of a ball at various times. Here see. Here 0, 1 second, 2 seconds, 3 seconds. The time and the position ball also changing like this. So here velocity t is equal 0, 1s, 2s, 3s, etc. like this. So on close observation we find that when the ball moves here down the inclined plane, its speed increases gradually. And the direction of motion remains constant. Direction is constant and also speed also increases here. See, children, see this figure. Next, again we take one inclined plane and take a ball and push it a speed from the bottom of the inclined plane. Bottom of the inclined plane, so that it moves up. Here velocities 1s, 2s, 3s like this. So we have to observe the speed changes. The speed is changes, but the direction of motion remains constant. Clear, children? Next, once you look up the fan, children, once you look up the fan, what type of motion is rotating? Once you look up the fan, what type of motion is rotating? It is in uniform motion. Yes or no? It is in uniform motion. Now we learn uniform circular motion. Here see, uniform circular motion. So motion. What is meant by motion? Motion means a body needs to be moving. Motion means a body needs to be moving. And circular. Circular means path of the moving body is a circle. Yes or no? Next, uniform means body is moving at a constant speed. Body is moving at a constant speed. So, body moving in circle at a constant speed is called uniform circular motion. Understand, children? So, here see. So in your textbook one see ma. So here with a stone which is tied to the end of a string continuously. Now draw a path of a motion and velocity vectors. Here we have to draw a path and velocity vectors at different positions. Here not in same position, here in different position. So now assume the speed of a stone is constant. So it is clear that the path is a circle and the direction of velocity changes at every instant. of time, but the speed is constant. Here the speed is constant, but velocities changes at every instant of time. Yes or no? So we have to observe from above this activity. The speed remains constant, its velocities changes. Then how do we calculate speed? Speed is equal to distance by time. By using this formula, we have to calculate the speed. Next, observe the motion of a object thrown into air. How do we observe? See, throw a stone into air while making some angles with the horizontal. Not vertical means this one, horizontal means this one. So we have to make some angles with the horizontal. Now observe the path take by it. Now you have to draw one path also of the velocity vectors. So in the above activity, you might have noticed the speed and direction of motion both changes continuously. Both changes, speed and direction of motion both changes. So we have to conclude speed changes with the direction remaining constant and the direction of motion changes with speed remaining constants. Both direction and speed change simultaneously. So motion of an object is said to be non-uniform when its velocity is changing. When the velocity is changing, the motion of an object is said to be non-uniform when its velocity is changing. Up to here clear, children? Next, acceleration. Acceleration. How do we experience acceleration in real life? How do we experience acceleration in real life, children? Suppose if we are traveling in a bus or a car, when the driver presses the accelerator, the passengers sitting in the bus experience acceleration. So our bodies press against the seat due to acceleration. Yes or no? So acceleration basically tells you that the rate of change of velocity of an object. So what is meant by acceleration? The rate of change of velocity of an object is called acceleration. Acceleration. So acceleration is equal to change of velocity by time taken. So here acceleration is equal to changing velocity by time taken. Here see children, everybody. So you have here two velocities. One is initial velocity, another one is final velocity. So here acceleration we consider small a, and here one is final velocity and another one is initial velocity. So v minus u by t. T here time and v is final velocity and u is initial velocity. Okay children. So next, coming to the units of acceleration. Units of acceleration. So once always remember children, if you want to find units, you should know the formula. You should know the formula. So from the formula only you get units. Clear children? So what is the formula of acceleration? A is equal to v minus u by t. Yes or no? So here numerator this one is denominator. So in numerator we have changing velocities. Clear? In numerator we have changing velocities. In denominator we have time. Clear? So in here series system and an SI system we have to find the units. In series system the velocity of vector centimeter per second and time, yes, seconds. So therefore centimeter per second square. In SI system velocity meter per second and time second. So therefore in SI system meter per second square. So velocity is a vector and acceleration acceleration is also a vector quantities. Velocity and acceleration both are vector quantities. In exercise system or series system, the units of acceleration unit is centimeter squares in series system, meter per second square in SI system. Okay, next velocity and acceleration both are vector quantities. So we have to say the magnitude and its direction, both we have to know, say the magnitude and direction. Why means acceleration and velocity both are vectors, so we have to know the magnitude and direction. Okay children, that's all for today. I hope all are understood the class. Thank you. We will meet in the next class.